Right. So let me go with my own pace. Then you can ask any doubts if you have. Okay. So with respect to space program in India, as far as Indian science is concerned, many things are happening, no doubt about it. But we have to be very much aware about space, nuclear, and defense. Apart from that, Industrial Revolution 4.0. What is Industrial Revolution 4.0? What is Industrial Revolution 4.0? New technologies, artificial intelligence, IoT, cloud computing, all robotics, nanotech, all is being pursued as a fourth industrial revolution. More things are evolving in this. So, recent development in these areas is a must. With respect to machine learning, which of the following news are happening? Not every minute detail. IIT Madras will give many new developments. Very small development, we may consider it as small, but it took 3-4 years of research. That is not our area of interest. Sunday Hindu will publish many things. Okay, on that selective research, what Indian Institute of Science is doing, what IIT is doing. Some they have created a new material which is applied in spectrometer. Not that small things. For them it is big, but we as a generalistic thing, how the technologies can impact in a bigger way. Okay, 3D printing. Have you heard about 3D printing? It is called as additive manufacturing. What is it called? Additive manufacturing. Additive manufacturing means, suppose I want to make this chair. How I will make? I'll attach. I'll take one big block of wood, cut it, remove the external things, and try to create a shape. Yes or no? Lot of wastage is there. You can't make complex structures with ordinary traditional manufacturing. Yes or no? It will take a lot of time. Imagine the shape of the ear. It's a very complex thing to make. Whereas when I'm doing additive manufacturing, I will make a 3D image of it, give it to a printer. The printer will have resins. They will build the shape of the ear layer by layer. Rather than taking a big block and removing the wastage and creating the shape, we are creating the shape, we are building the shape layer by layer. Complex tools can be made. Eyes, ears, nose, very big shape. Complex shapes or industrial tools can be made. This is called as what? 3D printing. 3D printing is just one dimension of additive manufacturing. Like that, many other technologies are also there with respect to additive manufacturing. What is cloud computing? What is the difference between local servers and clouds? Okay, so like these technologically we have to study with respect to UPs, both in prelims and mains. In prelims, they will ask the technology, they will say, which of the following are the applications of cloud computing? A, B, C, D, E options. More than one answer. Only one, 2, 3, 4, right? Okay, so you have to know. If you look at the syllabus, UPSC main prelims, there is no syllabus. Yes or no? Only brief intro or one-liner is there, current developments. Anything from the last 2 years is important as far as prelims is concerned. With respect, especially with respect to science and technology. Don't go for only 1 year. We have to go beyond that. Especially Hindu and Government of India mindsets. Okay, whatever reports they are asking. This is a very quick intro of science. Now, when we are looking at the diagram on the back, you see these white dots are the satellites released by various countries. If you see, there is a big concentration below 200 kilometers. Yes or no? In between, there are satellites, but they are less. Above, at one particular orbit, around 36,000 kilometers from the Earth, there is much more orbital satellite concentration is there. Right? So, why an orbit is going around and how it is, if I leave this bottle, if I leave it, it will drop because Earth's gravity is pulling. But why they are not crash landing onto the Earth? Satellites are going around the Earth. Why? Because they have velocity. They are moving. They are not stationary. They are not stationary like the bottle. So when we impose a velocity, another force will come. It will create a balance. The object will not fall. This much basic, you know. Why Earth is not falling into the sun? Because Earth is moving in an orbit. That orbit can be circular or elliptic. Anything can be possible. circular orbit or elliptical orbit. With respect to Indian space program, the main organization doing Indian space research is ISRO. Now, ISRO centers are located throughout the country. We need to go, what are the main areas which are being located, like here, see, what is the location of Bailalu, where liquid propulsion laboratory is located, where solar observatory is located, what is its significance. So you need to have a brief overview of various ISRO centers, very brief. Yes or no? So this is ISRO, from ISRO website only we have taken. Please look at, briefly study the functioning of various ISRO centers. That is one aspect which you have to cover. Now, by going back, these are some of the facilities. Look at this master control facility. When a satellite is launched, it should be controlled. We have launched a satellite. It is roaming around it. We have to receive signals, control it. That is being done by which facility? Master control facility, located at both Bhopal and Hassan. Suppose we are sending satellites into the space, or we have deep space planetary missions like Chandrayaan, Mangalyaan, all this. Just see here. Yeah, for Chandrayaan, Mangalyaan, all these, they are far away. Mangalyaan is going around 250 to 225 million kilometers. How many kilometers? Roughly 225 million kilometers is the average distance between Earth and Mars. We are sending the orbit, we are controlling it. So we need to have very big antennas, 32 meter, 18 meter diameter, big antennas are required. Separate network is there. What is the name of that network? Indian Deep Space Network. Receive signals from far-flung missions, interplanetary missions for the Earth, from where we are sending on Earth, these centers for ISRO. Vikram Sarabhai Center, main research center for ISRO. Like this, briefly look at various ISRO centers. That is one dimension which we have to look at. Now, it's a very quick review of orbits. Earth is there, Sun is there, Earth is rotating in an elliptical orbit. If you see it here, Earth is rotating here in the elliptical orbit here. When it is coming nearer to the Earth, its speed will increase or decrease? Speed will increase or decrease? When it is coming nearer, speed will be more. When it is far away, speed will be less. Because when it is nearer, force of attraction called gravitational force will be, in order to compensate, the speed will be high. So as the distance of the orbit increases from the Earth, speed of the satellite will increase or decrease? Decrease. Yes or no? More the nearer, more the speed of the satellite required in order to maintain its orbit. Okay, so this is one dimension which we have to look. Now, when we are looking at the orbits, I want to cover these things. So I'm going just to, in order to introduce various dimensions for you. Anything, if you are unable to understand, I will give you 10 minutes extra at the end. You can ask doubts. Now, the orbit around the Earth can be both like this manner. Please look at this. Pole to pole. Yes or no? Or it can be like this, around the equator like this. It can be with some angle around the equator also, like this. Okay, two types of orbits you have. I can launch the satellite like this, or with a tilt around pole to pole. This is north pole, this is south pole. Yes or no? So this is another way in which we have launching. When you are launching satellites in this manner, this is called sun synchronous orbit. Which orbit? Sun synchronous orbit or polar orbit. Because it is going from pole to pole of the Earth. Whereas this type of orbits are called as geosynchronous orbits. Okay, two type of orbits you have. In the same manner, you will be having two type of satellites also. When we are looking in the context of satellites, broadly in India, we have classified the satellites into two types, Earth observation satellites. Earth observation satellites. Another aspect is, anyone? Communication satellites. Communication satellites. These are the broad type of satellite categories which we are launching. Two type of orbits we saw. What are the two type of orbits? Polar orbits, sun synchronous orbits. Right? Generally, in polar orbits, we will launch Earth observation satellites. Generally, exceptions are there. Generally, we will launch Earth observation satellites in which orbit? Polar orbit. Communication satellites, generally, we will launch in, see, this is not sun synchronous, this is geosynchronous. Okay. Generally, we will launch communication satellites in geosynchronous orbits. So what is the purpose of communication satellites? What is the difference between Earth observation satellites and communication satellites? Earth observation satellites will access or will process lot of information related to natural resources on this planet, whether with respect to location of various resources, whether with respect to climate, whether with respect to data, we want to know about forest resources in the country. Multiple times they will scan the earth and they will make data out of it. Agriculture, how much of paddy is grown in a particular season, Earth observation satellite. What is the temperature changes on ocean surfaces around the Earth observation satellites. So these are multiple times you have to get information and process it. So this is the application of which type of satellite? Earth observation satellites. Whereas communication satellites, as the name says, to establish communication, whether it is mobile phone technologies, yes or no, whether it is private defense, security, national security links, e-governance applications, communication satellites, weather reports. We want to continuously observe Bay of Bengal, how cyclones are formed, what is the temperature on Bay of Bengal. Continuously we can observe through which type of satellites? Communications. So disaster management has both. Earth observation satellites are also used. Communication satellites are also used for disaster management applications. So generally two type of orbits, two type of satellites, and a similar classification with respect to two type of launch vehicles. Okay, I'm just simplifying the things. Two type of orbits, two type of satellites, two type of launch vehicle. What is a launch vehicle? The satellite has to be kept in an orbit. Who will take from here to there? Yes or no? That vehicle is called launch vehicle. India prominently has two type of launch vehicles as of now. PSLV and GSLV. Polar satellite launch vehicle and geosynchronous satellite launch vehicle. So in the same analysis itself, we have here two types of launch vehicles, PSLV and GSLV. Okay, in fact, India has developed these launch vehicles in various stages. If you look at stages of India's satellite launch vehicles, this is the way in which India's satellite launch vehicles got developed. First 1 and 2 satellite launch vehicle and ASLV are gone now. They are long back. Now, if you see here, we are using both the PSLV and GSLV. GSLV has two variants, GSLV Mark II and GSLV Mark III. Basically, here in the description, if you see here, this is the payload. Payload means what? Satellites. We carry the satellites through this launch vehicle. Now, this different launch vehicles will have different stages. Stage 1, stage 2, stage 3, stage 4. They will have different fuels. Okay. In GSLV, you have 3 stages. In GSLV Mark III also, you have 3 stages, but with little advanced versions. So each vehicle has been developed by using different fuels and different technologies. In the same way, their carrying capacity also will be different. If you look at polar satellite launch vehicle, the weight of the maximum weight of the satellite it can carry is it will go around 1800, roughly 1800 kg. Whereas if you go for GSLV Mark III, it is going for 2200 roughly. Whereas GSLV Mark III is going for 4 tons satellite. Like the capacity is being increased. Very important aspect you have to know about PSLV. PSLV is used only for polar satellite launch vehicles is a misnomer. The name says polar satellite launch vehicle, but it is used both for polar orbit as well as geosynchronous. We are mostly dependent on PSLV till now. Many launches, more than 50 launches has been there for PSLV. It is used for both polar orbit as well as geosynchronous. Heavyweight communication satellites, we are directly relying only on GSLV Mark II and GSLV Mark III. As the name says, geosynchronous satellite launch vehicle. So heavy communication satellites, geosynchronous orbits, we will launch. When we are talking about geosynchronous satellites or orbit, there is a special case here. If you come back to the original picture here, why this one orbit here? Why this one orbit here? If you see around 35,700 or in the previous figure here, the number 35,786, if you see it here, this number around 36,000 kilometers. From there, there is a special orbit. That orbit is called geostationary orbit. What is the orbit? Geostationary orbit. The fixed distance of 35,786 kilometers or roughly 36,000 kilometers. The time period of rotation or revolution in that orbit is 24 hours. What is Earth's rotation? 24 hours. As this is matching with that, if you launch a satellite in that particular orbit, it will look as if it is not moving. So if you launch a satellite on Chennai, it will look as if it is just hanging on Chennai. Okay. Only one special orbit has such phenomena because of the matching of time period. Earth's rotation, 24 hours, should be equal to revolution of the satellite. Okay, that's the reason in the initial figure, many satellites are in which orbit? In this orbit. Okay, you can see many satellites which are accumulating in that geostationary orbit. Okay, so that was a special case of geosynchronous orbit itself. Now, if you see very quickly, polar satellite launch vehicle stages, if you see the stages, polar satellite launch vehicle has 4 stages. Apart from the 4 stages, you have booster rockets here. These are booster rockets. PSLV has 6 booster rockets. How many? 6 booster rockets. They are just strapped on motors in order to increase the thrust. When a rocket is going against the gravity, initial thrust should be strap-on motors, booster rockets to PSLV. Apart from these booster rockets, we have 4 stages. How many stages? 4 stages of PSLV. Stage 1 is solid, liquid, solid, liquid. Like that, 4 stages you will have for PSLV. This booster rockets or strap-on motors are also using solid fuel. Which type of fuel is used in rockets? Solid fuel. Okay. But PSLV. Only for PSLV I am talking here. Initial strap-on motors will be based on solid fuel. That's the reason we are calling solid strap-on motors. These strap-on motors are with solid fuel. Next stages, if you see, the 4 stages of PSLV, if you see it here, first stage is solid stage. What is the name of the fuel? HTPB, hydroxyl terminated polybutadiene. These names are not much important, full forms, just to know the fuel. HTPB is used in which stage? First stage, solid stage. Is it a liquid or solid? Solid stage type of. Second stage is a liquid fuel which is using UDMH, unsymmetrical dimethyl hydrogen. UDMH. Only this you can remember. That is solid or liquid? Liquid stage. In liquid stage, in second stage, we are using which engine? Vikas engine. The name of the engine developed by ISRO, you might have seen the movie, that is called Vikas engine. Okay, so the same question I have asked in the morning also. In how many places Vikas engine is used? Common answer is only second stage of PSLV, which is absolutely wrong. PSLV second stage uses Vikas engine, no doubt, but it is not the only place where Vikas engine is used. We will see. We'll slowly see at the end in 5-10 minutes, we will see where all Vikas engine is used. So in second stage also, second stage is liquid stage, which uses which engine? Vikas engine. Third stage is also solid stage. If you look at the solid stage aspects here, here also we are using the same fuel, HTP. Fourth stage is a liquid stage. But observe here, there is a different fuel used in the fourth stage of PSL. We are not using UDMH, we are using MMH, monomethyl hydrogen. This is also liquid stage, but different fuel, Vikas engine is not used here. So, at the end, PSLV has 4 stages: solid, liquid, solid, liquid. Okay, second stage of PSLV, only it uses which engine? Vikas engine. This is about PSLV. In PSLV, the strap-on motors, if you have, it can be used without strap-on motors. If you are using without strap-on motors, its version is called PSLV 4 alone. CA means 4 alone version. So different versions, XL, QL, DL. Okay, with respect to if you are using 2 strap-on motors, it is called DL version, PSLV DL. You will be looking at different news in the paper, right? With respect to PSLV. What is PSLV? QL, PSLV, QL means it will use 4 strap-on motors. PSLV XL means it will use 6 strap-on motors. 0, 2, 4, 6. Additional strap-on motors which we are using with respect to PSLV. At the edge, you have this, right? With respect to here, you can see it here. These are the things. Maybe I am unable to point out here clearly. These circulated things are nothing but strap-on motors. Okay. Yeah, that's it about PSLV. If you look at GSLV, GSLV, 2 types are there. First type which we are looking is GSLV Mark II engine. This GSLV Mark II engine has 4 strap-on motors. How many? 4 strap-on motors, 4 liquid strap-on motors. What is the strap-on motors in PSLV? This is GSLV. What is the strap-on motors in PSLV? Solid or liquid? Solid. In solid, will we use Vikas engine? No. Solid means no. No Vikas engine. Vikas engine is only for liquids. Now, this strap-on motors of GSLV will also use Vikas engine. Okay, so the strap-on motors of GSLV Mark II will use which engine? Vikas engine. Not only that, GSLV has 3 stages. If you look at GSLV, the first stage of GSLV is solid. Second stage is liquid. Third stage is cryogenic. Okay, the term cryogenic means low temperature. What is the meaning of cryogenic? Low temperature, very low temperature, not 20 degrees, 30 degrees, minus 112 degrees, minus 130 degrees. So this low temperature science is called as what? Cryogenics. The purpose of having cryogenics is at a very low temperature, we can have liquid hydrogen. You know water vapor, standard example. Water vapor above 100 degrees, water will be in which form? Gaseous. Below 100 degrees, liquid form. Below 0 degrees, solid form. These temperatures are different for different animals, different elements. Yes or no? So for hydrogen, the liquid temperature below which the hydrogen will be in liquid form is very low. That's the reason at such low temperatures we want to use that fuel. That's the reason we are creating such low temperature conditions in which sciences, right? So the engine which is used is also called as obviously which engine? Cryogenic engine. So the third stage of GSLV Mark II in next version Mark III is which engine? Cryogenic engine. Solid, liquid, cryogenic. Okay, so this is the three stages with respect to GSL. It will also have, as we are looking at a variant here, it will have strap-on motors also. It is GSLV Mark II. Okay, so if you look at the diagram here, these things. Just a minute. So look at here, these things are strap-on motors, beyond which you will have three stages: stage 1, stage 2, and stage 3. Top stage is nothing but cryogenic stage. Above this, you have payload satellites. Okay, yeah, now you can. Yes. Vikas engine means liquid. Yeah. Liquid, where only in GSLV Mark. Okay, so first stage, see, this is just strap-on motors. After strap-on motors, you will have stage 1, which is solid. Then you have liquid. Then you have cryogenic. Okay, I'm just discussing about strap-on motors. Now, if you see the three stages, these are the three stages. Apart from, yeah, you can ask me later. Okay, apart from here, apart from three stages, I am talking about the cryogenic engines which are being used. So if you see here in the first stage of PSLV is solid. In solid stage, which fuel you are using? HTP. Again, same HTP. Is it solid or liquid? Solid. Okay. Second stage is liquid. In this liquid stage also, we are using which engine? Vikas. Second stage, liquid stage. Which engine is used? Vikas engine. Third stage is which stage? Cryogenic stage. In cryogenic stage, we are using liquid hydrogen and liquid oxygen. What are the fuels which are used? Liquid hydrogen and liquid oxygen. That's the reason it is called cryogenic, which we are using very low temperature gases. It will give very high efficiency burning, and it will give very high thrust also. That's the reason the capacity of GSLV Mark II and Mark III is increasing more than PSLV. PSLV has a capacity of 1800 around. GSLV has more than 2000. GSLV Mark III has 4,000. Like that. Okay, that is happening because main contribution is coming from which stage? Cryogenic stage. Imagine lot of heat. The launch vehicle is going in the Earth's atmosphere. It is burning like anything. Yes or no? We are shielding. The materials are shielded so that they will not burn. But high temperature is there on the outside. But in the inside, very low temperatures. So that is the rocket science. Your parents will use, your friends will use. Is it rocket science or what? To go and get that supermarket tomatoes, is it rocket science or what? Why so special about rocket science? Look at the challenges we have. Outside, very high temperature. But inside, low temperatures. Still that is maintained. Small leak, one small leak, collapse. Whole system will collapse. Okay, so like that, with such efficiency, ISRO is building these space or rocket launch vehicles. So this is about only GSLV Mark II. If we go to next stage, which is nothing but GSLV Mark III. What is the fifth generation? See in the figure which I have shown it here. Yeah, you see it here. This is stage 1, first generation, second generation, third generation, fourth generation. GSLV Mark III is called as fifth generation. Capacities are also increasing like that. Now, if you go to GSLV Mark III here, GSLV Mark III, observe the difference between GSLV Mark II and GSLV Mark III. You see GSLV Mark II here, it has strap-on motors. It has strap-on motors. There are 3 stages built inside. Here, whereas with respect to GSLV, GSLV does not have strap-on motors. The boosters themselves will act as a first stage. Okay, on the right side and left side, you have S200 boosters. Are you able to see it? I'll show it right here. This one. This itself is a booster propellants, which itself will form 2 booster stages. They themselves are stage 1. Okay, so this is stage 1 itself. They are using solid or liquid? Solid stages. So stage 1 of GSLV is always solid. Second stage is a liquid stage, which is inside. Can you see this? They have pointed out like this. Okay, this is second stage. This black one is a cryogenic stage, which is the third stage. So second stage, as it is a liquid stage, it will also use which engine? Vikas engine. Okay, third stage is cryogenic. Above that, you have payload here, which it can carry the satellites. Okay, this is the payload, which will carry the satellites. So ultimately, to make a gist, where Vikas engine is used, Vikas engine is used in liquid stages of ISRO. Not all liquid stages. Which liquid stage of ISRO is not using Vikas engine? Cryogenic, we can't call it as liquid stage. Say cryogenic stage. Gases are there in liquid form. Cryogenic, Vikas engine anyway is not used. Which liquid stage of ISRO's rocket launch vehicles is not using Vikas engine? PSLV stage 4. PSLV stage 4 is a solid stage or liquid stage? Liquid stage. Will it use Vikas engine? Apart from that, all the other things with respect to, try to list out here. I'm listing, try to list along with me. Second stage of PSLV. Yes or no? Not only that, strap-on motors on GSLV Mark II. Yes or no? Then comes second stage of GSLV Mark II. Then second stage of GSLV Mark III. In all these 4 dimensions, liquid engine is used, especially which engine? Vikas. That's the reason Vikas engine contribution is very high for ISRO's program. A question can come, who knows, in the interview also or in the mains, discuss the significance of Vikas engine or discuss the developments with respect to engine sciences. What are the varieties of indigenous development of engines he can ask? Not only when he asked about engines, we have to talk about Kaveri engine, defense. We have to talk about scramjet engine. Then we have to talk about Vikas engine. Don't worry, I'll tell other 2 as we slowly go into defense and other areas. Okay, so this is one important engine. Always this Atmanirbhar Bharat, Make in India, indigenization of technology, probable questions. Yes or no? So what India is doing on its own, what India is achieving on its own, all important developments are probable questions. Okay, so this is the manner in which we have to look. So another important point we have to know with respect to cryogenic stage. In the cryogenic stage, if you see, you have liquid oxygen, liquid hydrogen, and the third liquid is used, which is nothing but liquid helium. This liquid helium is not a fuel. It is there to maintain the pressure in the chamber. So in cryogenic things, 3 liquids are used. Hydrogen, combustion is done with the help of oxygen, and the third liquid called liquid helium. These are all PT points. Okay. So if you go back, if you now come to how the satellite is launched, if you see the satellite which is going, It is going every time after certain stage, each stage, stage 1 will be gone. See, stage 2 will be gone. Stage 3 will be gone. Stage 4 will be gone. Finally, what will remain? Only satellite will. Yes or no? It will be rotating around the orbit. So, is PSLV or GSLV or other launch vehicles, are they reusable? Are they reusable? No. PSLV technology is there. Every time a new satellites or a group of satellites are built, ISRO will use it again. It will make it again. So PSLV is not reused. We don't have a reusable launch vehicle. See here, this is NASA's. It is a reusable launch vehicle. If you look at the figure here, in the diagram here, you see here, this aircraft, these are the fuel tanks which we are having, which NASA is having actually. These fuel tanks will be gone. Only this part. This is just like a flight. It will be launched in here. You will have a payload. Satellites will have. This will go. It will launch in the orbit and it will come back. We don't have a reusable launch vehicle in India as of now. So ISRO has made a reusable launch vehicle technology demonstration. It has. In experimental manner, they have done a reusable launch vehicle. So if you see it here, reusable launch vehicle here, just to experiment they have done, they have launched the satellite along with the carrier. This is just like a flight. It has crossed 100 kilometers. How many kilometers? 100 kilometers. Actually, the definition of space is above 100 kilometers from the surface of Earth is called as what? Space. So where did space start? It's about 100 kilometers. So we have launched the satellite, launched the launch vehicle. It has went above 100 kilometers and it has come back also. It has splashed, landed. Okay. So this is just a technology demonstrator, TD. We don't have a complete reusable launch vehicle yet. ISRO is planning to implement it or make reusable launch vehicle. Okay, so that is one latest development which will be happening, which we have to follow. Next important development with respect to ISRO is space capsule. So in the sense, if you are sending astronauts or if you want to send some instrument and get back it, see the distance is very high, 625 kilometers. So some capsule is orbiting at such high distance, we have to bring it back. When it is re-entering, Earth's atmosphere will exert lot of force on it. It will burn, it will try to burn. That instrument or that capsule should be safe. Without getting burned, it should safely reach Earth. When I am saying safely reaching the Earth, it should not land randomly anywhere. It has to land at a specified location. Yes, sir? What if it is landing on the peak of Mount Everest? Run. They will die there itself. Yes or no? So we have to launch it at a specific re-launch. It has to come back. And we have to recover the capsule properly because in the capsule, astronauts may be there. Instruments will be there. Your UPSC books will be there. Material, direct question papers. You don't know how important it is. So we have to recover them safely. So we have, ISRO has conducted this space capsule recovery experiment also. So this is the second important development which we'll be seeing, especially with respect to Gaganyaan. In Gaganyaan, astronauts will be there. They have to be recovered. Yes or no? We can't send them right there, tata, bye-bye, goodbye. We have to take them back. Yes or no? So space, their capsule has to be recovered. So this also experiment we have been doing and still much more improvements are happening. Next important technology is air breathing propulsion. When we are talking about air breathing propulsion in this diagram, actually, if you see it here, the rocket is going like this. In this direction, the rocket is going and it is absorbing the air. You see it here, while it is moving, it is sucking the air. Because air contains oxygen. Our Earth's atmosphere has abundant amount of oxygen. Rather than me carrying oxygen fuel, I can directly suck it from the Earth's atmosphere, at least for few hundred kilometers. Beyond in space, you may not have enough amount of oxygen. Understood. But within the Earth's atmosphere, we will have enough amount of oxygen. So rather than me carrying it as an extra burden, I can suck it from the atmosphere, and while I am going in between, the ignition will be there. Here you will have ignition here. It can burn and it will release the output. So this technology is called as what? Air breathing propulsion technology. The improvements are happening with respect to space launch vehicles. One is reusable launch vehicle. Second dimension is space capsule recovery. Third aspect is air breathing propulsion. Okay, this latest development we have to follow. Any major breakthrough in this area? It's not that only rocketry movie is there. It is in the news. Hey, he got Padma Award, so only we will read Vikas Engine. No, no. Apart from Vikas Engine, we have to look at other aspects also which are happening in ISRO. A very small here. Yes, yes. We are using this technology. Developments are happening. Scramjet engine has some applications with respect to this. I'll tell on engines. I will tell. Yeah. No. They are sucking. The speed is coming because the amount of fuel I am burning. For burning, I require which gas? Oxygen. There is not a compression. It's not combustion. Compression is happening here. I have to compress the air. This thing will just create a high pressure for the air which is being sucked. Just suck it, use the oxygen for burning and release the exhaust. In fact, it is having hypersonic speeds also. Okay, as I don't have extra baggage. Imagine I don't have a bag. Can I run faster? Yes, that extra baggage is oxygen cylinders. That I am not carrying. I am directly using from the oxygen present in the air. Okay, so these are the developments which we have to follow. A small question, if you see, why rocket launching stations are located on the east coast, that too nearer to the not Earth, equator. My point of reference was, if you see, famous rocket launching stations on the planet are located nearer to equator. Three reasons can be told about it. Why on the east coast and why on nearer to equator? First thing is, Earth is rotating from west to east. Yes or no? So simple example, when there is a bus, when you are getting down from the bus, running bus. Okay, don't try it now, gone. Intermediate age is gone, +1, +2. When you are getting down from the bus, will you get down in opposite direction or what? You saw someone going, you want to go behind. You are going in opposite direction or you will fall. Your shape will change. Yes or no? Why? Because there is an extra force coming. If you are going in the same direction, if you are launching the vehicle in the same direction as Earth is rotating, sir, why Earth is rotating from west to east? You go and ask nature. You go climb a hill. Why it is rotating only like this? Why not like this? It is rotating. It has formed like this, so it is rotating in one direction. We have named it that as east and this as west. So Earth is rotating from west to east. So in order to aid or help ourselves with Earth rotation, our rocket launch pads would be better if they are located on which coast? East coast. Okay. Second important reason is, if some failure happens, they can directly fall into the ocean. On west coast, suppose ISRO, Sriharikota location is somewhere located on Mumbai, near to Mumbai. If something happens, the rocket will fall on mainland, dangerous. Okay, that's the reason we have kept it on east coast. Why nearer to equator? They will try to see as nearer to equator as possible. That's because when it is nearer to equator, the gravity, imagine if you look at the rocket launch vehicles here or pads, rocket launching pads. Go on. Yes. Can you come? So if you look at the rocket launch vehicles or rocket launch pads, we have located it here, Sriharikota. It should be as nearer to equator as possible because Earth is not a perfect sphere. It's a geoid. It is having a bulge at equator. Gravitational force will be very high at equator. Okay, so sorry, very low at equator because distance will be high, whatever formulas we have. The gravity will be less at equator. It's not a zero gravity, but a lesser gravity. So when we are nearer to equator, the pull force of the Earth, will it be high or less? Less. Because gravity, this gravitational force will be less nearer to equator. So the launch vehicle should be as close to equator as possible. That's the reason French Guiana here, Florida here, and India, they have located it as nearer to equator as possible. A question comes, sir, if it is nearer to equator, why not in Andaman and Nicobar? Andaman and Nicobar are much more closer. Yes or no? Why not in Kanyakumari? Why we have kept it around Telangana, sorry, Andhra Pradesh and Tamil Nadu border? It can be as nearer to Kanyakumari. Andaman is much more nearer to equator. Why we have not kept it? Please tell. I guess with respect to land. Yes, we can't forget Sri Lanka. We can't have a emergency where we have launched it from Kanyakumari. It has crash landed on Sri Lanka. Safety and security will be issue. If you forget small logistic issues will be there. Everything you have to transfer it from the mainland. Difficult. That's the reason USA didn't have the rocket launch pad on Hawaii. Hawaii Island belongs to USA. Logistically, it is very difficult to implement everything there. That's the reason we have chosen a safe place above the Sri Lanka zone so that a Bay of Bengal good safety zone will be there. Okay, so these are the issues which we are looking at. Now, what is the purpose of ISRO? What are the applications of ISRO? Anything which we are doing, ISRO, whatever it is trying to do, it will try to benefit the development of the country. The applications of ISRO will be very high with respect to agriculture. Like each area itself is very important. In agriculture, ISRO programs or ISRO's data is useful to tell which crops are being grown. What is the area of this crop? How much demand is there? How much supply is there? What about soils, alkalinity? What about the quality of soils? What's happening to the black soils? What's happening to the laterite soils? All this data is very important. Yes or no? Not only that, with respect to renewable energy, what is the best location for locating wind? What is the best place to locate solar? How much of biomass energy is there? How much of suitability is there with respect to wave energy, tidal energy, locations? All these data inputs will get from the ISRO database. Yes or no? That is also good. Forest and environment. Applications of space technology for environment. Suppose we want to know how ISRO is used specifically for environmental protection in India. So write a question. Discuss the applications of space technologies for environmental protection in India. Discuss the applications of space technologies for environmental protection in India. Okay, how ISRO's applications can be used for environment or climate change studies in India. Try to work out for 2 minutes. Okay. See, there are other online videos are there, morning classes. I will go somewhat slower. Somewhat more information also you will have. So if you are having any gap, you can refer that videos also. Okay, because we have to cover this whole science and tech in 10 hours, 2 hours this whole week. We will see how much we can cover. Any difficulty you can really speak. Till now, is it going smoothly? Am I slow or fast? Shall I make it somewhat fast, right? Yes, many things I am telling. Okay, let's see. Yeah, so that's what. If you have read it, because you are doing many things along with your career and other things, so try to read on your own. My inputs will help you to go in proper, simple manner. Okay, try to concentrate. It will be easy. It is not rocket science. Okay, we just follow some basics. So try to write how ISRO can be used for environmental protection. Answer, Nico. For 10 marker question, how many minutes you will have in mains examination? 7 minutes. Okay, you have only 7 to 8 minutes only per 10 marker question. So I'm just giving you 2 to 3 minutes just to have keywords. How ISRO's applications can be used for environment. See, here, when I am calling applications with respect to environment, what are the applications of ISRO with respect to environment? ISRO can have two types of satellites. Yes or no? One major satellite is communication satellite, collect lot of information, produce, provide information. Other type of information or satellites is remote sensing. Earth observation is also called as remote sensing. Okay, Earth observation satellites are also called as what? Remote sensing satellites. Now, remote sensing satellites can collect lot of data. Think about environment. How much of start from the top of the country, go till water, applications will come. Top of the country, Himalayas. How much of glaciers are melting? What is the flow of rivers? Himalayan rivers. Can you monitor that with respect to ISRO applications? Yes. How much of environmental impact is there on Himalayan glaciers? If these glaciers are not there, that's a very big issue. How much of excessive tourism potential is happening in the Himalayan region? deforestation is happening in the Himalayan region. Very important for us. So we can monitor using ISRO applications. Himalayan ecosystem can be monitored with the help of ISRO. Then we can talk about pollution levels in the rivers. How much of pollution? Environment, na? So how much of things are getting polluted? If you see from Haridwar to Kanpur, Ganga will be a kind of good quality water will be there. As it enters the towns, gone. I'm not talking about Yamuna. Yamuna is polluted at Delhi. Okay, but main Ganga, Yamuna is a tributary. Main Ganga river will flow with very fresh amount of water. By the time it is flowing into the UP towns, urban areas, Musi, Hyderabad, Musi was a life giver for Hyderabad. Now, if you go to Musi, it will be black. You have to Musi. Musi means you have to close your nose. So much of pollution. So, how much of water pollution in rivers, lakes, canals? How much of sedimentation in the rivers can be monitored? A dam is there. How much of sedimentation is happening? We can measure the flows of water in the rivers. Then come down. You have delta regions. In deltas, there is a special vegetation called mangroves. So, salt rivers, when a mixture of fresh water and salt water, there is a special type of vegetation called mangroves. Mangroves are very important for controlling storm surges, for controlling the impact of cyclones. Yes or no? So mangroves are very important for biodiversity. Humans, for the sake of agriculture, for the sake of housing needs, or for the sake of this firewood, all these needs, they are cutting down these mangroves. So mangrove vegetation can be monitored. Yes or no? We can monitor aquifers, surface water as well as groundwater resources also. So how much applications? We can monitor the status of coral reefs. You know corals? Yes or no? They are marine biodiversity. Corals are being built. They built on their own. Okay. Look, what is the famous example of coral reef of India? Lakshadweep Islands. If you go to Lakshadweep Island, if you go and dig, will you get water? Groundwater? Lakshadweep Island, if you go and try to, if I put a tube well here, after certain feet, groundwater will come. Is it the same case in Lakshadweep? Lakshadweeps are coral reefs. You will not get in Andaman. Yes, because they are mountains. Andaman Islands are. What is an island? Don't think that island is something land floating. No, you have a mountain submerged by water. Top of that big area is island. In fact, they are the extension of mountains from Myanmar. In Myanmar, the mountains will extend and submerge under the sea. Andaman and Nicobar are linked with Myanmar mountains also. Okay, anyway, so coral reefs, Lakshadweeps are coral. Andaman also we have different type of coral reefs. Okay, with respect to Tamil Nadu, Sri Lanka, in between also there is coral reefs. Gujarat also there are coral reefs. We will send the fresh water from Kerala to Lakshadweep. Maldives also, India will send fresh water to Maldives. So when sea level is rising because of climate change, global temperatures are increasing, sea levels are rising. These islands will be under threat. Is ISRO data helpful or not? Okay, monitoring about coral reefs, biodiversity, to know about sea level changes, to know about temperature, overall temperature of India, average temperature, weather patterns of India, monitoring them, to know about monsoon, when it is hitting, how it is hitting, environment, huge role of monsoon is there. If monsoon gets disturbed, whole country will be disturbed. Agriculture will be disturbed, economy will be disturbed, huge difference. We can monitor drought, we can monitor forest fires. Yes or no? Disaster management is a separate thing altogether, but in environmental context, pollution, with respect to biodiversity, with respect to forest density, tree density in forest, what is the quality of forest which we are having? How much of greenery is there in Chennai? If an urban area is having no forest or no urban forestry, no greenery, only concretization is there, difficult. Yes or no? Average temperatures of cities is higher than surrounding village areas. Urban heat island concept. What is it called? Urban heat. All these are the environmental applications, not only with respect to India. We can collaborate with foreign institutions. International collaboration is required because climate does not harm only one nation. It is a global phenomenon. We are collaborating with France. We are collaborating with NASA for various environmental applications. So like that, the question can come on any one of these dimensions. Overall applications of ISRO, we can list out all these things: agriculture, renewable energy, forestry, rocks, type of minerals, geomorphology, governance applications. Directly from the village, feedback can be taken through people. Directly, the information can be sent to district headquarters. Like that, land resources, how much of wasteland is there, how much of urban area is there, how much of agriculture land is there, how much of fallow land is there. What is a fallow land? Which is not cultivated for 1 year, current fact. Okay, how much of wasteland is there, how much of wetlands are there, all these things can be managed. Then ocean science, sea level, temperature, surface of the oceans, what is happening, ocean resources also. Because ocean seabed has lot of resources. Fisheries, amount where we have maximum amount of fish, so that advisories can be given to the fishermen. Like that. What is the best place to go? All this ocean sciences, rural development. So write a homework question. Discuss the applications of ISRO for rural development. Discuss the applications of ISRO for rural development. You can write 10 markers, 1.5 page. How ISRO is useful for rural development. Okay, urban development, planning is there. I'm just telling, I'm not telling rural development, I will tell tomorrow. For urban areas, how much of population migration is happening? What is the demand of the future? How to plan? How much metro line should be there? How much of housing needs should be there in urban areas? Planning with respect to where should be industrial area, where should be residential areas, urban governance, direct applications through ISRO. Yes or no? Monitoring migration patterns, establishing this transportation networks, monitoring them, pipeline networks. All these things can be done with respect to urban areas. Smart city, real smart city will have space applications inbuilt in them. How we can think. Northeast space application is also there. How ISRO's technologies can be used for the development of northeastern region. A special center is there in Northeast India, Northeast Space Application Center. Overall Space Application Center is in Ahmedabad, where various applications of ISRO will be given to the common use. Okay, but separately for Northeast also we have. So you have to continuously refer at least once or twice Northeast Space Application Center as well as Space Application Center Ahmedabad. Directly they will give how space is useful for disaster management. Full list they will give in this manner, in this manner, in this manner. That is nothing but UPSC question. UPSC examiner or any examiner, when he is setting the question paper, he has to give a reference key. From where he will give reference? My slide or what? No, no. From where he has to give reference? Outside material or what? No. Xerox center material. Anna Xerox center. No, no. He has to give government resources. ISRO annual report. Space Application Center report. That would be the direct answer. Okay, so like that you have to prepare for this examination. Water resources, weather and climate, national meet outcomes, all these things are enabled. So ISRO, ISRO is doing all these things not just for the sake of time pass. It is doing this development so that it can directly benefit the Indian national development. Common man, everybody has mobile phones now. Enabled by whom? ISRO. Okay. So look at that homework. ISRO is specifically ISRO contribution is important for rural development in the. Okay. Some advanced things we will see now with respect to resources here. See, I'll come back to these things later. First, we will cover some at least prelims aspects now. Chandrayaan 1, Chandrayaan 2, old missions are fine. Please look at some videos of these things. I have already explained these things before. I want to look at some specific aspects now. Yes. This is the thing which we have to look. Many things are coming. AstroSat. AstroSat is India's first dedicated observatory in the sky. Rather than having an observatory on the planet, on our surface, we are putting that observatory directly in the sky. The speciality of this AstroSat is it will capture images in three rays: X-rays. Look at here: X-ray, optical, and ultraviolet. In 3 zones, in 3 different ways, it can capture images. That is the specialty of which mission? AstroSat. First dedicated Indian astronomy mission. It will capture images in how many wavelengths? 3 wavelengths. What are those? X-ray, optical, and UV. We'll look at images. See, in the night time, some animals can see during night time. How? They are looking at a different frequency. The wavelength of their eyes, which they can recognize, is of different frequencies. UV rays, infrared rays also are there, depending on the heat. So like that, we want to receive objects which are in different frequencies. We want to study about the universe. So which mission? AstroSat, India's own observatory. Another important dimension with respect to scientific objectives of AstroSat. What is the purpose of this AstroSat? You see, to understand binary star systems. What are binary star systems? One star will be rotating around other star. Okay. To know about magnetic field, these neutron stars are different stages of stars. Sun is burning. Why Earth is not emitting light? Sun is emitting light. Because Earth does not have that hydrogen fusion reaction. In the sun, hydrogen is mixing with hydrogen and it is emitting a lot of energy. So once the hydrogen fuel is gone, will the star stay? It will collapse. So when it is collapsing, different types of stars it will form. Stages it will form. Red giant, black hole. All these are the different stages of stars, depending on their. So you want to study when stars will collapse. What are the stars beyond our galaxy? See, if you look at it, there's a video, maybe in nanotechnology, I will show you. The universe has 100 number of stars. Yes or no? No. You have millions of stars. In those millions of stars, just one galaxy name is Milky Way. Milky Way has millions of nobody can count. In that, one star is sun god. Okay, so one sun, we call it God, but scientists will look at it what? As a nuclear fusion reaction. Okay, so this star, sun, around it has few planets. People are, once they called 9, now we are calling 8 planets. In that planet, there are many cities. In that city, Chennai is one. In Chennai city, there are many buildings. This building is one building. In this building, there are many rooms. You are in one room. In this room, there are many chairs. You are sitting on one chair. But you are a big man. Okay, we don't know. We don't have answers to many things. 97% of universe matter is unknown to us, even today. That's the reason it is called dark matter. Dark means don't think it is black in color. We don't know. Africa, dark continent. It is not a racial expression. People don't know. They didn't explore Africa, so they call it as what? Dark continent. 97% of universe is unknown to us. So you want to know all these things. Okay, answers, hidden secrets. We are busy in Netflix, Prime. Okay, but scientists are looking up. We are looking down. People are looking up. Okay. So here, detect new bright X-ray sources. Deep field survey, all these technical things, you can leave it, ignore them. Those are too much technical. So one more important area which we have to look at is privatization in space. We have allowed private companies to launch vehicles slowly. We are allowing in India. For that, you have three dimensions. One is in space. In space is a regulator. When private person is allowing, what if the private company launches a satellite for terrorist organization? One dedicated satellite. Yes or no? Difficult. So this is a regulatory mechanism. What if the satellite launched by a private organization collapses? Who will regulate? Okay, so that is the role of in space, which will act like a contributor and it will regulate the space. Another organization is there, which is called NSL, New Space India Limited. New Space India is a government-owned company. This company will sell space products. Suppose ISRO, using its PSLV, NSAL will come to ISRO. It will say that I will use your PSLV and I will sell this PSLV rocket launching thing to some other countries. Other countries, suppose let's like Nepal. Nepal wants to launch satellite. It can't have its own technology. So it will provide some money for us, buy the services, and we will launch Nepal's satellite into the orbit. So all that is facilitated by which company? NSA. Another third dimension is there, which is nothing but Antrix Corporation. Antrix Corporation is a very old one, 1992. It will just sell. It is also commercial arm. NSIL and InSpace are very recent. Whereas Antrix is 1992 commercial arm. Whatever ISRO applications are there, it will directly sell to the map, sell to the world. Suppose ISRO is having some maps. Who will sell that? Commercialization of ISRO's activities or ISRO's applications is under whose control? Antrix Corporation. So NSIL, the previous NSIL, is a big brother of Antrix, is a small version of NSIL. Like that you can. So these three dimensions are developed. Apart from this, they will allow the private sector also to participate in a very big manner in space sector development. Need not be. Any applications also it can monetize. ISRO assets monetization. Suppose a new company comes. It says that it has its own rocket launching technology with it. It just wants to utilize the launch pad of ISRO, which is in Sriharikota for a day. Like a function hall is not owned by the person who is married. He will rent it for a day. That is facilitated by whom? NSA. Antrix does not have such bigger role. 1992, long back they have, when we don't have a strong privatization, they started it to commercialize the applications developed by ISRO. Okay, when NSIL will become very big, maybe Antrix will be faded out. Okay, that is the application with respect to Antrix, InSpace, and NSA. Okay, these three. Apart from these three, you have private players also coming into the picture. In fact, these three things will help the private sector. So in the future, we may have a Ambani or a Birla or a Tata directly launching a satellite. Okay, more efficiency may come. Already ISRO is specialized to have satellites being launched at very low cost. When private players come into picture, more efficiency may come in the future. Look at BSNL. Once upon a time, for BSNL connection, only one government agency, it used to take 9 months after you apply. Private people came. BSNL also changed. Private people also became competitive. Within 10 minutes, you are getting a mobile connection. Yes or no? It will increase the competition and it will have its own benefits. These marketing people or this private sector will develop more applications like space tourism. Yes or no? What is space tourism? A person without any long astronaut training, directly he can go spend some time in the space. It's the next big thing. In the future, space travel may happen, whether we will see it in our lifetime or not. In the future, it may happen. If nuclear fusion technology is developed, where high amount of that 1 kg of nuclear fuel is enough to run Chennai for 1 year, roughly. If nuclear fusion technology is developed, there is no end to energy. Yes or no? Very fast space applications can be developed. Vehicles can be developed. Okay, as we are very perfectly destroying the earth, we are finding other planets. Rather than maintaining here the decency here, we are busy in destroying. So we have to look at other dimensions also. Yes or no? So things are anyway, movies are also being coming in that theme. We are going in that direction. Okay. Right. So this is this thing. Another important dimension, basically Amazonia is a old one, but 2 years back issue is also important. We have to cover 2 years issue when we are preparing. Why so much of importance to this C51 is, it is the first project of NSA, where a satellite is being launched to study Amazon forests. Okay, first project of NSA, where NSA has given the PSLV services to the outside countries or agencies. Okay, so that is PSLV C51. A very important development recently has been there, small satellite launch vehicle. We have seen PSLV, we have seen GSLV. Now we are talking about what? SSLV, small satellite launch vehicle. Rather than launching big satellites, I want to launch Anna satellite, small, micro satellite, nano satellite, which can be assembled. The small satellite launch vehicle can be assembled in 3 days. PSLV will take 60 days. Okay, small applications, education purpose, research-based applications. They have developed a new version called SSLV. Okay, this SSLV is very significant when for privatization also, up to 500 kg satellite in 500 kilometers, below 500 kilometer orbits, or 300 kg into sun synchronous orbits. We can 500 kg, 300 kg level satellites. They are less than that also. Nano, micro, small satellites can be launched. Okay, it is a 3-stage all solid fuel vehicle. SSLV is having liquid stage or not? No. It has 3 stages. All the 3 stages are solid. So when all the 3 stages are solid, any role of Vickers engine? Any role of cryogenic engine? No. So basically liquid engine or cryogenic engine is there to go to higher distances with higher carrying. Anyway, the purpose of SSLV to small distances and small payloads. Weight of the payload is also okay. Till here, please ask, just go back and ask any doubt. Just give me a minute. Yes, ask any doubt if you have till here. Bola. Communication satellites are preferred in geosynchronous. Yes. See, the doubt of your friend is communication satellites are preferred in geosynchronous or geostationary. Why is the question? Relevant to doubt. Because you are making a phone call. That signal has to be received by a satellite then. The satellite, should it roam continuously or should it be stationary and accept your signal? Most of the communication satellites are launched in not only geosynchronous, but in geostationary. They will be continuously observing. That's the reason all your Tata skies will be looking in only one direction. Airtel also will look in one direction, but Airtel direction is different from Tata Sky. But all Tata skies, only one direction they will see. All Airtel dish DTH will see in one direction. Okay, in order to establish that link, we want that stationary. That is the speciality of geostationary. That's the reason in the first slide, many satellites are being congestively shown in which orbit? 36,000 kilometer orbit. In future, people will fight for it. Like we are fighting for land on the planet, people will fight for a satellite space in the. But who wants space? Anyone wants space? No. It is a global fund. Everybody will try to exploit it as much more as possible. Anything else? Any other question if you are not following? Shall we go ahead? Yes? With respect to, so SSLV is an important development, all solid state fuel. China's space mission, see, we are not much interested. Of course, strategically, we have to see the competitor interest. Here, the point of reference is the significance done by China is China was the first country to send a satellite on far side of the moon. Where? Far side of the moon. It has launched there. So when I am saying far side of the moon, the speciality of the moon is Earth's rotation, moon's revolution, they become matched. Okay, because of that matching, what is happening here? We are only looking always only on one side of the moon. Wherever you are, whether you are in USA, whether you are in Chennai, whether you are in Australia, you will be only looking at which side of the moon? Only one side. Always that tree shape you can think, or rabbit shape you can think. Some people will tell there is a tree, old woman is sitting behind that. What are those? Those are nothing but shadows. The deep zones are there, craters that is being shown reflected as a shadow. So you can imagine whatever shape you want in that picture. You will see your face only some things, or someone else's face there, Chandani. Okay, so we are only seeing one side. Moons may have different shapes. Full moon to new moon, direct changes are happening. That pattern we are able to see only which side? China was able to send a probe on the far side of the, which is a special. Okay, so that's the reason China is doing its own space station. Questions may come. What is the technologies needed for space station in order to India to have its own space station? What we should do? Is it important for India? Like the dimension also we have to think. Okay, significance of moon's mission, significance of Gaganyaan mission. Whenever an important mission happens, we have to look at its applications. Okay, why we are doing that? Why we are doing Gaganyaan? What is the use of doing Gaganyaan? Are we competing with other countries just for the sake of pride? If someone gets a car, suppose you don't have that income, but still you want to have that car, you will take a big loan and buy that car. Is it the case with respect to Gaganyaan? No, definitely not. Why we are doing Gaganyaan? Why now we are doing Gaganyaan? Like that you have to think. Think and come back today. Tomorrow I will answer this question. Okay. So coming to certain terms are there in this S&T terminology, especially with respect to space, like dwarf planets. Okay, in the solar system, there are few important dwarf planets like Eris, Pluto. Pluto is no more a planet; it is a dwarf planet. Size is smaller than planets, and they don't have a fixed path. Planets have a fixed orbit, whereas Pluto sometimes it will become 8th, sometimes it will become Okay, dwarf planet. So you have this dwarf planet, round shape, Eris, Pluto, Make, Haumea, and Sirius. Important dwarf planets. Okay, this terminology you have to know. Their locations are also important. Where are these dwarf planets located? Where is Eris located? Is it between Mars and Jupiter? Like that questions can. I'll show you in a figure, maybe in the next slide. Another terminology is planets, brown dwarfs. What are exoplanets? Planets, you know. What are exoplanets? Planets around some other stars. We are only one among millions. So there are planets, rocky materials revolving around different stars. Those are called as what? Exoplanets. Is there life on it? We don't know. Yes or no? We don't know. We are still trying to look in that manner. Okay, fine. So brown dwarfs are in between planets and stars. They are neither planets nor stars. When a star is destroyed, if it is not having enough fuel, it may turn into a brown dwarf. So brown dwarf is not a complete planet. It is a stage of a dying. Sometimes it will have its bright radiation still present on it. It may collapse or it may remain like that. Okay. Another important event which is seen here is gravitational lens. What is a lens? If you see, what is the work of a lens? If you are traveling in a two-wheeler or any four-wheeler, on the mirror, objects in the mirror are nearer. Vehicles in the mirror are nearer than they appear. Okay, what a lens will do, suppose this is a concave lens. Light is coming here. From here, light is coming, candle. It will reach. This lens will bend it or not? It will bend it. So for a person like me who is watching here, as the rays are bent, if I look this ray, I will feel as if the candle is here. Yes or no? This is happening because of the bent of the rays caused by this lens. The same phenomena is happening in gravitational lensing. What is happening here is, actually, if you are able to see, there is a shadow here, which is Earth. This is Earth. Imagine here you have Earth. Okay, all these are the stars, galaxies, and many things are there. I am observing the light rays coming from a faraway galaxy. Okay, that is emitting the light. That light, this light energy is being subjected to all these stars. Will these stars have a very large weight or a small mass or large mass? Large mass. They are exerting so much of force on it, even light is bending because of their high gravity. So the light rays which are coming from this galaxy, rather than reaching it like straightly, they will reach in a bent form. So for us, the galaxy will appear as if the galaxy is somewhere here. But actually, the galaxy is at some other location. We feel the galaxy is located at some other place. But actually, it is located in other direction because we are able to see it like this because of the lensing effect created by various galaxies. So this phenomena is called as what? Gravitational lensing. Okay, so simply they will confuse. Gravitational lensing is about bending of gravitational waves. Is about using high-end lenses, big telescopes to see, to observe planets. Like that, simple statements they will. Basically, it will bend the light rays in order to create a different position of the galaxy. Okay, this is observed. New discoveries are being done. Corona. Anyone familiar with the word corona? Whole world is familiar. Only if you are wearing masks. Whether we should wear masks in the coming 2 to 3 months, we will know. When a new variant comes, we don't know. It's all highly uncertain. So sun's corona. When I'm saying sun's corona, don't think that sun is wearing mask. The upper region of the sun is highly mysterious. When a star is there, we don't know anything actually. We feel that science has developed in multiple ways, but in actuality, many things are still unknown. So, how to control this iPad, that itself is a big challenge for me. Forget about space science. Okay. So, when we are looking at this dimension of sun, the beauty of sun is a star. At the surface of the sun, you have around 6,000 degrees centigrade. Okay. Center of the earth also has around same temperature. Center of earth. So much of high temperature. Anyway, on the surface of the sun, you have roughly this much. Sir, how did you know? Did you go there with a thermometer? No, radiation pattern, they are being emitted. We can estimate. Okay. So around 6,000 kilometers, but just above sun, for a few kilometers, just above the sun surface, as I am going away from the sun, temperature should increase or decrease. Imagine that we are going away from a candle. When we are going away, temperature will increase or decrease? Decrease, na? When we are going away. Okay, but for sun, till now there is no answer. You find out, you will get Nobel Prize. Just a few kilometers above sun, the temperature will be in millions of degrees. Why? There is no answer yet. We are sending missions. NASA is sending missions to understand it. European Space Agency is sending it to understand it. India, Aditya L1. Okay, to understand one aspect of it. Okay, so sun's corona, highly mysterious. We don't know, maybe corona, disease also named like that corona because nobody knows about it, whether how it is coming, how it is going. Anyway, on lighter terms, so this is about sun's corona. Why that high temperature is there? Still there is no. Okay, so that's the property of sun. Many things of sun is unknown. Like, for example, if you see it here, with respect to sun, star, north pole, south pole, is there? Yes or no? For roughly around 11.5 years, imagine it around 12 years. For every 12 years, north will become, magnetic north will become south. South will become for just 12 years. Whereas earth also same thing is possible. Not possible, it is happening. North pole, south pole, this reversal is happening for millions of years. Every few million years, Earth's magnetic north and south will interchange. In geography, you will see that in seafloor spreading. Magnetic properties of the ocean deposits will change for every few millions years. That's because Earth's magnetic field is reversing. Very interestingly, for sun, it is only 12-year cycle. So when these rapid changes are happening, sun may also emit solar flares. Okay, it will have coronal mass ejected. Huge radiations will be emitted. Earth has a magnetic field. That's the reason Earth is protected. Earth has its own magnetic field, yes or no? Whether it is reversed or not, it has its own magnetic field like this. Earth's magnetic field like this, it will protect or it will trap all the radiations here. They will be rotating around in the magnetic field itself. Moon does not have this magnetic field. That's the reason Chandrayaan 1, 2, 3 will study the impact of the solar radiation on the. It's very difficult to survive on Moon with the present technology because it is not protected like Earth. Okay, so that is the way. Anyway, we will scientists are looking at all these dimensions, sun's corona and all those things. A very dangerous thing, we can call it a dangerous thing or a new discovery, depending on how you view it. There is a issue called, there is an event or a phenomena called black hole. What is this black hole? Why it is black means anything entering it will not come out. Its gravity is so high. Its gravity is so high, it will suck anything, even light. Even light entering into it will not come. It's difficult. So much of gravity it has. Such black holes are present in the universe. Who did major contribution on it? Stephen Hawking. Okay, so why this? Then how do you know that there is this? Nothing is coming out. Why? How we will see? At the edges, there will be a bending of light. At the edges of the black hole, you will find the properties of the light which is having that scattering, and we will identify it as a black hole. So all these years, we were searching for black holes. Many black holes got discovered, but we forgot to search our own backyard. This black hole, Sagittarius A, is at the center of Milky Way galaxy. Whole Milky Way galaxy slowly will be sucked into Sagittarius A black hole. Okay, don't worry. By the time all your UPSC attempts will be gone, you will be gone, I will be gone. Lot of time is there. But we have a black hole at the center of our galaxy. That beautiful black hole is called as what? They named it as Sagittarius A. So don't think Sagittarius A is a nearby star. Sagittarius A is what? Black hole at the center of Milky Way galaxy. Okay, so that's what we are looking at these things. Now, may not be. May not. If that is the case, we might have discovered long back. We have at the center of our own galaxy. Right? Now, lot of things are being talked about space. From where space will come? Generally, standard definition is above 100 kilometers, which is called Karman. Above 100 kilometers, we are calling it as what? Space. Okay, 62 miles or 100 kilometers. So International Space Station is around 330 to 410 kilometers. What is this range? It has to be 330, 340, 400. They gave this much big range, 330 to 410. What is this? Why? No. It's not like that. Why this big range means this space satellite, space station is not going in a circular orbit. It is going in elliptical orbit. It is just going in elliptical orbit like this. Earth is there. It is going in elliptical. So here distance will be less. Here distance will be. Okay. In that manner only we are doing it. Okay. So look at these exoplanet missions. These missions are dedicated for finding other planets. Mostly by NASA, whether it is Space Telescope, Hubble. You have Hubble, beautiful thing with respect to a lot of contributions have been done with respect to Hubble. Hubble Space Telescope, Spitzer is there, Kepler is there, TESS is there, Webb Telescope is there. So John Webb Telescope, very recent addition with respect to this. Then future missions are also there. On the ground also you will have observatories, no doubt about it. 30-meter telescope, Hawaii. Many countries are collaborating and building this on Hawaii so that we can observe space. Okay, there is another observatory called Chandra X-ray Observatory. This is by NASA. In order to honor Indian scientists, whether we honor it or not, other countries are able to honor it, fortunately. So Chandra X-ray Observatory, this is there in picture from last 20 years, long back. It is observing in which medium? X-ray. X-ray frequencies it is observing. Chandra X-ray Observatory. So much of kilometers it has traveled, this much of data, 23 trillion bytes of data. Okay, around 2,700 trips around the world. There is an observatory directly in the space. Okay, the images which it sends that will be used by NASA. So these are the two important space missions. One is Solar Orbiter by European Space Agency and NASA. Another thing is the Parker Solar Probe. This is the mission which will go to the nearest distance to Earth, to Sun. Sorry, Parker Solar Probe will go as much nearer to the Earth as, as much nearer to the Sun as possible. As much nearer means don't think 1 kilometer, 2 kilometer. 6.2 million kilometers is the nearest way which it is going. The distance between Earth and Mars, it will vary. Average is 225 million kilometers. How much? 225 million kilometers. Average distance between Earth and Mars. Between Earth and Moon, it will vary. 3 to 8 lakh kilometers also it will go. Now in December it will be around 4 lakh kilometers. How many kilometers? 4 lakh kilometers. That is a level of distances which we are working on. So this Parker Solar Probe, that is only by NASA. Solar Orbiter is by both European Space Agency and NASA. In the solar system, we have another dimension called asteroids. Okay, asteroid belt. If you see this big things between Mars, Earth is there. Actually, if you can see the picture, Sun is at the center. 4 orbits are there, which is nothing but Mars. Between Mars and Jupiter, this is Jupiter's orbit. You have a belt of big belt of small shapes. They are called as what? Asteroids. Why they are not planets? Because they are not like a good circular shape. They are just random rocks. They are rotating around the sun. So this belt is called asteroid belt. These asteroids can be present anywhere. Don't think that asteroids are present only between Mars and Jupiter. No. Majority of the asteroids are located in the, maybe theories say that some planet has collapsed, burst, and all the rocks got formed. Many theories are. But when you have these kinds of asteroids around in the same orbit in which you are going, suppose there is Earth. In the Earth, so this is Sun at the center. This is Earth. In the Earth's orbit only, there are some other rocks which are traveling in the same orbit as Earth. Those type of asteroids are called as Trojan asteroids. Okay, Jupiter has, Earth has. These Trojan asteroids we have. They will be rotating in the same orbit of the planet. Okay, these are terms which we have to look into. Now, when this asteroids, when they have different paths, see, look at this red color. Green color is Earth. It is rotating around the sun. Earth is also rotating around the sun. Unfortunately, when both come together, collision may take place. Probability is there. That's the reason they are called as potentially hazardous objects or asteroids. PHA. What if an asteroid is coming and hitting the Earth in the next 2 to 3 years? What solutions we have? We'll ask Bahubaliya to come and stop. What can we do? One thing, what solutions? Crazy thoughts, okay? Agreed. How? God, deviate. How they are going to deviate? So much of energy, who will have? NASA will have. How? They are using nuclear missiles. They'll go and they'll carry the mission and go and blast it also. If it is a small thing, see, if that is the case, Earth might have been collided by many asteroids. Why we are safe? Because whenever an object enters Earth's atmosphere will burn it. It will make it as a small object. Just by the time it reaches the surface, it will be nothing. So we are protected like that. But what if the size is bigger? then comes the danger. In fact, a theory says moon is created like the mountain. Some object, very big asteroid came and collided with the Earth, leading to the separation of moon. The place from which it got separated, they became oceans on the planet, depressions. Those depressions are filled by water later. So that is a theory. So the probability is there, an object hitting the Earth. Fortunately, all these space missions are continuously observing, they are predicting the data, they are seeing we are safe. As of now, we are very safe. There is a possibility in the future. So NASA is planning for such missions. Those missions are the missions. We'll come back to these slides later. Just Da Vinci. Da Vinci is for Venus. Why study asteroids? Significance of asteroids. Dart impact, double asteroid redirection test. This is done by NASA in order to divert the asteroid and, if possible, destroy the asteroid also. Now, coming back to our own Trojan things and all these asteroids. Yes. Look at this figure. This mission, this is potentially hazardous. The red one is potentially hazardous asteroid. There is a mission, very important mission you have to know with respect to Japan, Hayabusa, not the bike. Hayabusa mission. One is also there. Two also there. This mission will go to an asteroid present between Mars and Jupiter. It will go to the asteroid and come back to the Earth with a sample. Okay, that mission is called Hayabusa. It came back actually. Okay, another such mission is there with respect to this Hayabusa mission. It is going to which asteroid? If you can see it, Ryugu asteroid. What is the name of the asteroid? RYUG. This is the name of the asteroid from which Hayabusa has got a sample back to the Earth. Okay. Another such mission is there, OSIRIS-REx. This was previous prelims question. OSIRIS-REx is by NASA. It is going to get the sample from an asteroid called Reddy. It will come in 2023. It will be able to come back to the Earth. Okay. So such we are getting samples from other asteroids. Okay. That is the level of things which we are going. Now look at the location of this. Look at the location of Cirrus. What is Cirrus? We saw. What is Cirrus? Dwarf planet, not asteroid. Dwarf planet. Among this asteroid is a round spherical geoid-shaped asteroid is a dwarf planet, which is Cirrus. Look at the position of Makemake. It is located after Pluto. Look at the position of Eris. Okay, they are located after. After Pluto also you have these objects, which is called as what? Kuiper. Okay, so if you look at the picture of our solar system, Sun is at the center. The whole solar system is called heliosphere. Don't confuse. Heliosphere means some sphere on the Earth. Okay, what is cryosphere? What is cryosphere? I said cryogenic engine. What cryo means what? Low temperatures. Cryosphere means glaciers. Low temperature surfaces on polar regions. Study of these polar regions is called as what? Cryosphere. That's name, geography name. Anyway, heliosphere, whole Earth. Then there is a heliopause, whole not Earth, whole solar system. Then you have interstellar space gap. After that, you have Oort cloud. All objects which we don't know are acting as a barrier, protecting. Maybe this Oort cloud is a protector for solar system. Who knows? Okay. After that, you have a nearest star called Alpha Centauri. Alpha Centauri is not a galaxy. It is the nearest star. Okay, then you have AC plus 17388. We are not interested in all that numbers. Okay, so this is a general location of our beautiful solar system. See, this gap, nothing is there, no objects. Heliospace, interstellar space, this just differentiates our star with the rest of the universe. Nothing, no radiation, no objects, no comets, nothing. Okay, between object and object, between star and star, the gap which you are looking at, they are referencing that. Now, a very important discovery has happened with respect to asteroids. This effect is called Yarkovsky effect. What is the effect name? Yarkovsky effect. Now it will terrify scientists. It may not terrify us, but it is terrifying the scientists. What is the impact of this effect means? Suppose an asteroid is spinning around the sun. Every day it is receiving energy and it is emitting energy. Yes or no? Earth is also emitting. Every on during when daytime part of the earth absorbs. Night time releases. Moon is also releasing. That's the reason moon is bright. If you go to moon and see, you will feel earth as a bright star, not star, bright planet, blue planet. It will emit light as if someone has kept blue light on earth. Images are there from Apollo missions. From the moon, they have taken images where you will feel the earth as glowing blue planet. Why it is emitting? It is releasing the things which it has absorbed. Now, the terrifying thing which they have found out recently is when a bloody asteroid is emitting that radiation, it will drift. Drift means it will go in different. Every day it is emitting and it is drifting. So, asteroid is there. We predicted the path. It will not come. But every day it is drifting. So, this effect also we have to take into consideration while studying about asteroids. Okay. So, why it is drifting? No answer. Okay. So, that effect is about Yarkovsky. Sir, what is the use of reading this? Scientist will take care now. We will eat our masala dosa. Yes or no? The only thing is UPSC may ask. Yarkovsky effect recently seen in news is related to A. Semiconductor technology, B. Vaccine production technology, C. Asteroid path prediction, D. None. Once if you have read, you will tick. Okay, simple things. They will expect you to know. What is it? What is its important? That's it. This is not 2019-99 data. All these things are the news from the last 2 years. Okay. So like that, we have to see gravitational waves have been discovered. What are these things? What is its importance? That will continue. Okay. Anything doubts which you have, you can ask now. Lay. Earth's part is maintaining constant. Asteroids are drifting. Emitting. That's the mystery. These are small objects. Okay. Planets definition is when they go in a fixed orbit.